Hello, everyone. My name is Dale Reel. I'm director of the Williams Club, and we welcome all of you to what will be, I think, a really marvelous evening. So we're here thanks to the Princeton Club, whose facilities we use. This is an all-college event, and I think it's an all-person opportunity to learn about the eclipse from what seems a funny way to put it, but Mr. Eclipse. The Professor Pasachoff shared with me, I think it's not quite out yet, but the August issue of Scientific American has an 8-page article by him about this eclipse and what it means. If I remember correctly, and I may be off a little bit, he's been at 65 of these of solar eclipses in his lifetime, which to me is quite remarkable. Anyway, thank you all for coming, and Professor Pasachoff, thank you for coming.
Thank you very much, everybody. Thank you for coming. I'm glad to see so many people I know from years back, including from my Williams days. My very first student, Fred Harris, is here somewhere. There he is, who came with me on an eclipse in Prince Edward Island when I was only 10 days on the faculty. We had arranged that in advance. And my friend Chris Cerf from college, who's over here, was on that trip with us too. And there are other people who've been with us on eclipse expeditions since then. And maybe I think we just started here. And maybe we will have encouraged by the end of this next hour for all of you to participate in some eclipse expeditions that we have in the future. I am not going to talk about the 65 eclipses that I have been at, though I do like giving that lecture. And I'm just going to start with some of the most recent ones. But also, at the Halley's Comet year, I started working with a local art professor, Roberta Olson, and we have done a number of things on the relation of art and astronomy over the years. We're working on a book now about it. Apparently, there's some glitch in the projection, so I'll describe what is on the first few slides first. It turns out, and how many of you are from Princeton here? We're joined with the Princeton Club. It turns out that a Princeton alumnus named Howard Russell Butler, who is related to another Princeton alumnus, Butler, and there are walks and things on the Princeton campus, became an artist in his 50s. He had a physics degree, but he went and trained with Church in Mexico and became a portrait painter. And he was invited on the eclipse expedition of 1918 by the U.S. Naval Observatory because as a portrait painter, he was known for being able to take notes very quickly and ultimately make a big portrait. And he said something to the effect of, I usually get 8 hours for a portrait, but this time I had 2 minutes and 8 seconds. So he did a big picture of the eclipse, an oil painting of the eclipse. Dale? Technical difficulty. Okay. So he did a big painting of the eclipse, which is about yay high, and he got very interested. But this eclipse of 1918 was the last time that there was an eclipse that went across the continental United States from coast to coast. But he got interested. He did 1923 and 1925, and you'll see some pictures in a few minutes, and he tried to interest the American Museum of Natural History in building an astronomic hall, which was never built. But he tried for a long time with plans, and then they went to all the rich people, the Guggenheims and the Rockefellers, and they couldn't convince them to put in money for this astronomic hall. And finally, the Zeiss people, a big German optical firm, with whose name many of you may be familiar, put in planetaria in Pittsburgh and Los Angeles and Chicago. Some of you may know the Adler in Chicago and the Griffith Observatory in Los Angeles, for example. And so it became a little bit of an embarrassment that New York City didn't have a comparable planetarium. And they convinced a businessman named Howard Hayden to build this planetarium. And of course, we all know the Hayden Planetarium here. And not only was the Hayden Planetarium an important thing for astronomy in general and the people of New York, but it was very important for training a number of young people, including my own training as a student at the Bronx High School of Science. And even before, I used to come down to the Hayden Planetarium. And I'm glad my friend Larry Goldhirsch from PS 114 in the Bronx is here today, because in that era, too, I used to go to the planetarium. And when Larry arranged the 25th reunion of our 6th grade class, and I came in the room and everybody was talking about what you did then, and I said I was an astronomer, somebody said, "Jay, you're the only one here who has followed through with his original idea." So many people ask me what the biggest result is in the scientific results we're doing. We're doing a lot of scientific things at this eclipse, and we have Nick St. Fleur from the New York Times here who's interested in some of those things and writing about some of those things. And I can say that I think that one of the biggest results of the eclipse will be the inspiration that it gives to some young people. There is historical examples of people who have been interested in science in general by eclipses. One of my favorite stories about that is actually Tycho Brahe, who saw the eclipse of 1560 as a young aristocrat in Denmark, and the prediction was off by a day, and he resolved that he was going to do better. And the king gave him an island, and he got tithes from the peasants on the island, not necessarily treating them as well as he should have. But he built the biggest pre-telescopic observatory at that time, and those results led to Kepler figuring out the laws of planetary motion, and is really in the line of the astronomy we have today. In fact, I even claim some pinhole camera images, crescents on the ground under a tent thousands of years ago, that led to the idea of a pinhole camera, that led to the idea of a camera obscura, that led to photography and lenses and the television and movies that we have today. So we can trace it all back to solar eclipses. Can we turn the lights down, Dale? Good. So in any case, I've had the pleasure of seeing a number of eclipses, and this gives more of a view of what it's like to be at an eclipse than a lot of the close-up pictures that you'll see later on. The sun and the moon are really fairly small in the sky. You can cover them up with your thumb at the end of your outstretched arm. You can try that with the moon at night. The moon is 400 times smaller than the sun, but it's also 400 times closer. So it more or less fits exactly over the everyday surface of the sun, plus or minus about 10%. And when it's average or above average in size, then we get a total eclipse when the moon goes across the sun. The orbits of the sun and the moon are inclined by a few degrees, so most months the moon goes around above or below the sun, but 2 or 3 times a year it at least partially covers the sun. And about every 18 months it goes right across the middle of the sun when it's big enough to cover, and also with that frequency it goes right across the middle of the sun when it's a little too small to cover, and a ring, a so-called annulus, is available at that time. So anyway, here I am here with Jupiter in the sky, and one of my students in the background, and some telescopes and cameras looking at an eclipse of the sun. So in the sun, we have the nuclear fusion that you all know about in the core, bringing that temperature to about 15 million degrees and Celsius or Kelvin. And then the sun gets cooler as you go out until you get to these outer layers. And it's all gas, of course, so there's no real surface, but we call the surface where it gets opaque, when you can't see in from the outside any further. So we call that the photosphere, from photos, for light. And on the photosphere, there are these sunspots. And then And then there's a thin layer around that of spiky stuff that glows mainly in the red light of hydrogen, and we call that the chromosphere because of all the colors when you look at its spectrum. And when that also gets covered up at an eclipse, the sky gets dark, the blue sky falls away, and we can see the corona, Latin for crown, that's been there all the time. It was up there today. Today it was behind a layer of clouds, but even if the clouds hadn't been there, it would have been behind the blue sky. So what you want to study the outer layer is to have the sun up at night. And that's essentially what we do with an eclipse. When we bring the moon across the face of the sun, we keep the everyday sunlight from hitting the surface of the Earth, from the atmosphere, and the sky doesn't turn blue, and we can study things around it. The corona has beautiful shapes, and I'm going to show you real pictures in a minute. But this is a diagram that was drawn specially for my article in Scientific American that Dale just kindly mentioned. And the corona, you'll note, has these streamers going out in all directions, held in place, and they are held in place by the sun's magnetic field. When there aren't streamers at the top or the bottom, north or south poles, which we see at this point in the sunspot cycle, then there are these plumes that come out, and that's one of the things we'll be seeing this year. How many of you have seen a total solar eclipse in the past? That's healthy. We'll work on increasing that percentage. How many of you are planning to go this August to see the eclipse? That's quite a healthy return. During the question period, you can each turn to your neighbor and or neighbors and try to convince them to come too. The eclipse is a real thing. This is a space view from a Japanese spacecraft, and you can really see the shadow of the moon go right across the Earth. And this was last year when we were in Indonesia to see that eclipse. The first map that really showed the path of totality going across the surface of the Earth is Edmund Halley's 1715 map that you see here, with the path going across England. He made these predictions, and then here, and I caused a small map of England describing the track. So we have an interesting history and real rare books. Marissa True, who is here, was in my rare book seminar of astronomy rare books at Williams College with the facilities of the Chapin Library at Williams College and some books in the collection of my wife Naomi, who is here, and me. In any case, Halley asked down here in the small print for everybody to observe and send in their observations. So this is what we now call citizen science. And when the observations came, there was another eclipse a few years later, and he was able to refine the path by about 40 miles, I think, at that time. And then the next eclipse went this way across the continent. So there will be a lot of citizen science participation of people across the country at this year's eclipse. But just what you were seeing at the eclipse here, you see it was a little tinged with the colors of be concentric with the moon, where I concluded it was the moon's atmosphere. So just what was going around on the sun and what this corona was not understood for a long time. And for a long time it was thought to be the moon's atmosphere. It was really in the 19th century that they realized it was part of the atmosphere of the sun. I keep trying to describe to people how important it is to be outside, that watching on TV doesn't give you the impression, because it really does get dark around you, and the shadows change, and the shadows get sharpened, and the light color changes, and it gets colder, and the wind changes. Clouds can change too, so it's even hard to predict clear weather, because clouds may form or clouds may disperse from the eclipse cooling. And I actually work with a Venezuelan physicist who was a Fulbright fellow at Williams 3 years ago and who arrived in the United States last night to come with us to the eclipse. We have weather equipment coming coming with us. I was actually awakened at 11:30 last night by the hotel at Miami Airport for my vouching for his room. But anyway, so Halley even wrote about the chill and damp which attend the darkness of the eclipse. And we're trying to look at how the animals relate to the eclipse too. So anyway, I've already given the background of this. Here are Howard Russell Butler's 3 paintings that stood in the old Art Deco Hayden Planetarium here in New York over the entrance to the planetarium from 1918, 1923, and 1925. So in 1918, the eclipse went from Washington and Oregon across the middle of the country and exited on the East Coast here in Florida. And in 1925, he was able to watch it from Connecticut. In 1923, it was, just clipped the California coast before going down to Mexico. And he had a studio in York, Maine, and observed it in 1932. And they're having an exhibit of a set of these pictures that they own at Princeton. The set in New York is full size. The Princeton one is half size. At the Princeton Library, they have a half-size set that's on exhibit now. And I was co-curator of an exhibit that's up this summer. If you're in the Los Angeles area, we have an art exhibit about the art of eclipses at Art Center College of Design in Pasadena. Anyway, here's the path of this year's eclipse, which you see is pretty close to what we saw in 1918. So here is the 1918 picture that he did. Obviously, he was observing through clouds. This is the silhouette of the moon. Sticking up at the edge of the sun are these red things that are called prominences, and then the corona here. And it looks like a solar minimum corona because it's extended at the equator, and there are more like plumes at the poles. You used to be able to do this with film, which was not sensitive and had a small dynamic range. The corona is 1,000 times brighter here than here, so no single piece of film or even electronics now just capture that all at one time. Here's the 1923 eclipse. This is called the diamond ring effect from when this last bead of everyday sunlight shines through a valley on the edge of the moon. And it was especially commented on at the New York City eclipse in 1925, which I'll come back to. So people look for the diamond ring effect, and here's Venus in the sky there. And then in the 1925 eclipse, so these are made from the originals that belong to the American Museum of Natural History, though unfortunately they're not on display at the moment. And just to give you an idea of the size of these things, these were a major undertaking for Howard Russell Butler. And then the 1932 one that he got from Maine, and here's really a minimum corona here. In 1925, we had a nice total eclipse that with a shadow coming down from Portchester through the Bronx and Upper Manhattan, and the electric company stationed people on every corner along Riverside Drive to try to detect where the limit was. We have recently had some mapping of the edge of the sun, of the edge of the moon, the 3D mapping by a Japanese spacecraft and now the NASA Lunar Reconnaissance Orbiter. So for the first time, we really do have an accurate view of all the mountains on the sun, and this has been recreated. And one of the things we will be doing at the eclipse is matching the so-called Bailey's beads of the valleys at the edge of the moon with that accuracy. But anyway, twilight will prevail in downtown Manhattan and Brooklyn, Staten Island, and Jersey. For the flash of a minute or so, stars will shine in the daytime. So here is how that eclipse came across, here with the lower limit reaching New York City and coming up through Cape Cod and out to the ocean. And here, January 24th, so will darken all Manhattan with some maps and pictures of corona. Light will disappear entirely north of 90th Street for a fraction of a second. Shadow will miss Brooklyn. You see, that's the news. That's there. Clear view, you know, top of the front page, above the fold. Clear view for eclipse here today. Experts to watch it land in an air. And then there was a dirigible that was supposed to go up, and there was a lot about it. And even then, they were stressing what the scientists were going to do, and we get new ideas all the time. We get new theoretical ideas. We get new instrumental capabilities. We're able to do new and better things all the time. And then the day after, they could report an eclipse 4 seconds later. So we don't have that discrepancy anymore. Now we can predict things more accurately, though that's not bad. It's certainly better than the day off that Tycho Brahe's prediction was in 1560. It thrills the people of City Halls to gaze. Corona divinely beautiful. So that's something I can really agree with, and I hope we all get to see the eclipse this year. And then the next eclipse that came through close to here in 1970, they gave some history here in 2137 BC. A solar eclipse was fatal in some historical stories. An eclipse right on time, unlike the one in 1925. Yesterday's solar eclipse was right on time, said Dr. Harry Krull, an astronomer at the American Museum, Hayden Planetarium, et cetera. Anyway, so what is a solar eclipse? So the sun is projecting the shadow of the moon on the Earth, and it makes a shadow that crosses the Earth, but then the sun is partly visible from above and below that part. So the central part is called the umbra, the shadow is called the penumbra. The umbra is going across the United States. It's only 60 or 70 miles wide this year, and it's going to exit in South Carolina here. But people to the north and south will see a partial eclipse. But the sun is so bright that it gets 1,000,000 times darker when it goes away. So if you have a 99% eclipse, 1% is still level, so it's 10,000 times brighter in the sky than it is during totality. So it's misleading to talk about a 99% eclipse because then only 99% is covered, but you still have 10,000 times more light than you would like. So anyway, the scale of the moon and the Earth is shown here. My friend Ernie Wright at NASA's Goddard Space Flight Center does these nice simulations. So to cover all the delicate shapes in an eclipse that you could see in the corona, the computer scientist Miloslav Druckmüller from the Czech Republic has put together these images taken by my colleague Alan Davis, who was a Williams student at the time, is now a graduate student at Yale, colleague Vojto Rusin from Slovakia, and some of my images have all gone together. Some 6 dozen images have gone into picking the best parts and putting them all together to show the shape of the corona, to show how the magnetic field is holding the corona in place. And this is at the eclipse in 2013 that we observed from Africa, from West Africa and Gabon. And during that eclipse, just before the moon covered the chromosphere, you could see some of the reddish chromosphere. This little bit of prominence has escaped and is being ejected. And these are called coronal mass ejections. And so they are going off to the side, and we were able to compare images taken over the hour and a half or so that the eclipse was on the Earth's surface and actually see motions and measure the motions. Now, these were going off to the side, but every once in a while you see one that's a halo. That means it's coming at you. And nowadays, with all our billion-dollar satellites in orbit, they can really be all zapped and killed by a coronal mass ejection. If we get notice of them by monitoring, they can lower the high voltage, for example, on a spacecraft, and save the spacecraft. There was a case where the Quebec power grid was down for a few hours, once from a solar eruption. So we are now spending more attention on what we call space weather, the interaction of the sun and the Earth. And you can see these coronal mass ejections that we now know a lot more about than we used to. So I want to talk about a few of the recent eclipses in particular. Here's the one in Gabon from which we took that picture. We were located as close as we could be to the center, but still on dry land. I have a sturdy base for our equipment. And then I'll talk about Svalbard up in the Arctic in 2015. The sunspot cycle has been known to vary for a long time. It was really only figured out as periodic in the 1850s, thereabouts, but then they can reconstruct older sunspots. But look what's happened in the 20th century, where there was a series of solar peaks about every 11 years, plus or minus a year or two. And this most recent peak is only half the height of the previous one. and close to a third the height of the one before that. Maybe there's some longer cycle. We just have to watch for another 100 or 200 years to figure that out. But we are now in the declining part of the sunspot cycle, and I'll say more about that later. In 2012, the eclipse started in Africa and went over the Pacific. And unfortunately, it was cloudy where we were on the ground the night before. We had learned that, and some of the people were able to go inland. I went up in a helicopter and out to sea, where we were able to go to look through a hole in the clouds and see the shape of the corona. This is looking through a filter. So these filters let only about 1 part in a million through of the light. So it can be very blue sky outside with clouds, but to see the sun, you actually need one of these filters. And these, now the technology has them available for very inexpensively, $1 or $2 commercially. My daughter bought 1,000 at 15 cents each for her daughter's school district. But we're very big on these filters, and in the task force on the eclipse of the American Astronomical Society today, there's some work on trying to tamp down some old responses that they expire after 3 years, and you should only look for 3 minutes, and there are going to be some statements out that that's no longer true. That might have been true 50 years ago, but not with today's Mylar technology. So anyway, here's the crescent sun here. And from the helicopter, you could actually see the shadow of the moon come in as the bright sun was covered. Here's a reflection in the ocean below, and then in totality, you can barely see the silhouette of the dark moon in the middle, surrounded by the corona, and then the shadow of the moon here in the sky. And then near the horizon, you're looking out beyond the umbra, and for the same reason that sunsets are red, you see a red horizon view. So some of our people had gone inland, just another side of the mountain range, and then there was a ship in the Pacific with some Japanese astronomers north of New Zealand. And so here's one of our pictures taken especially by some colleagues and students from Mialo, from the Mount Carbine site. You see a prominence there. You see the diamond ring on the edge of the sun. You see some prominences here. And this was taken especially by Ron Dantowitz's camera, which was known as a Red Epic, an IMAX quality camera. And you can see just longer exposures are able to show the shape of the coronal streamers. You see they're out in all directions because of a solar maximum. We took spectra also, and so here's a whole spectrum, breaking down the light into its component colors, the way Fraunhofer did, especially in 1816. And these are enlargements, and you can see in the enlargement that in the red there's a faint circle here, which is the light from a certain gas in the corona. We know it as the coronal red line for obvious reasons. Here you can see a little brighter one, the coronal green line. And these were discovered back in 1869 and 1870, but helium had been discovered the year before from this yellow line here, which didn't match the so-called D lines that Fraunhofer had found. So they called this one D3, and they said it came from helium because it existed only in the sun. And helium turned out to be a real element, as you know, one of the basic ones. Well, these were said then the next year to come from coronium, which, as you know, didn't last in the periodic table, but it took 70 years to figure out what it was. And it turns out that the coronal gas is so hot that it's driven off almost, or even more than half the electrons. So if you take iron gas with 26 electrons and you heat it a bit, it will ionize once, and you heat it more, ionize twice. To ionize it 13 times to get that coronal green line really requires it to be about 1.5 million degrees. And that's how it was discovered in the early 1940s that the solar corona is so hot. And just how it gets so hot is still the subject of controversy. The problem has been solved, as I like to say, but it's been solved in 12 different ways by 12 different groups of people. And so one of our main goals scientifically at this eclipse is to make some very rapid observations at high cadence, looking for differential predictions or verifications of one set of classes of another, whether there are fast oscillations on a certain size of loop or whether there are little flares going off all the time on such a scale that we call them nanoflares, with 1 billion of them at the same time. These are among the things that we would be doing scientifically at this eclipse. So after the 2012 eclipse that you just saw, there was an annular eclipse with a ring of sunlight showing, also in Africa, and before that there had been another annular eclipse to which we observed partly with a radio telescope in New Mexico, and we have recently been assigned time again on that radio telescope in New Mexico to make radio observations of the active regions of the sun at this eclipse. And then here in 2013, we were observing from Makango 2 in Gabon. And this eclipse extended even barely to the east coast of the United States. Some of my students tried in Williamstown to look very low on the horizon without success. But we were here at the peak place in Gabon, but you see the partial phases extended even up to Spain and southern France and almost all of Africa. But we could not go exactly where we wanted to go in the center line because we were told that we could be trampled by elephants. We were on the edge of the La Lope National Park, and we had to beware of the elephants. So in fact, we went a little further south to a village there, and we were well received by the villagers. The local park service had done some liaison work there, and here's a group from Williams College. Alan Davis, I mentioned before, is now a Yale graduate student. Mike Antronakis is New York, the manager of the Eclipse Task Force. Zofia here now has a PhD in sociology and is teaching. Michael Zeiler drew some of those maps. Marek Demiansky has visited us, et cetera. So here, and we didn't turn on the sound actually, but here is a 1 minute video of the eclipse. Here I am here, and you can see the close-up that Mike Kendrianakis made here with Michael Zeiler's wider field of view here, and you can see the diamond ring fading away, a little bit of the reddish chromosphere being overexposed there. Then that gets covered too as we go around doing our business for this time. Aram, you were not here at this eclipse. And Aram Friedman, who's here with us, made a wonderful wide field video of the 2009 eclipse, at which Charles Cow, who's also here, was with us, and Aram will be doing that again at this coming eclipse. So you can see that a minute is actually a fairly long time for an eclipse. You have plenty of time to look around, take your binoculars up, look at the shape of the corona. You begin then eventually to see some brightness occurring on one side, and you can stop looking with your binoculars certainly and turn away as soon as the diamond ring appears to make the totality end. So this was a 1 minute eclipse, and now we're going to have at least 2 minutes at this eclipse. The longest possible eclipse is almost 7 minutes, but we take what we can get. And what we want to get is totality when the sky is dark and you can see the corona around the moon in the sky, and not 1 minute later when the sky is blue and everything is just overexposed by the everyday sun appearing. Zofia took those pictures. And here's a composite by one of our colleagues from Greece, Paul Gonsasis, showing, again, one of these coronal mass ejections going out and the shape of the coronal streamers going in all directions. Here's the erupting prominence there in the chromosphere. And there is a very nice thing that online that any of you could start your day with every day called Astronomy Picture of the Day. If you just search for APOD or APOD in NASA, every day there's a new picture selected, and we're always very pleased when one of our pictures is selected. So this is a composite that we put together with our eclipse image in the middle, and then an ultraviolet view of the sun from space pasted on the dark silhouette of the moon, which otherwise would just be plain black. And then there are what are called coronagraphs in space. But in order to make the eclipse, they have to cut out this whole region here that, in fact, is what we see from the ground at eclipse. They just don't have the technology now to make as good an eclipse from a spacecraft. And that will catch up one day, but not yet. So this whole region here, where the space weather is formed, where the solar wind is formed, where you see the origin of these beautiful shapes, and can study the magnetic field and how it's formed above the active regions on the sun, which we can now see in the ultraviolet, is still left for us to do scientifically at eclipses. So there'll be a lot of these scientific observations made at this eclipse that's coming in less than a month now. Sometimes there are only partial eclipses where the shadow of the moon would go above or below the Earth. So in October 2014, for example, there was such a partial eclipse we observed from New Mexico, but there was a huge sunspot region on the sun at that time, the biggest in decades, that would have been visible even just looking with your eye through one of the filters to cut the intensity down, but it was that big. So it's fun to see all the eclipses, not just the total ones. But at that time, we were at the peak of the sunspot cycle here, and it was in fact a double peak because the northern hemisphere and the southern hemisphere peaked at slightly different times. In 2015, the path of totality threaded its way up the Arctic to the island of Svalbard, the archipelago of Svalbard that's controlled by Norway. The capital is Longyearbyen, after actually an American who was there 100 years ago. It's around the curvature of the Earth near the North Pole, which is here. This was latitude 78.5 degrees, so that circular shadow is just spread out because of the curvature of the Earth. And this was one of the only polar bears we saw. But in fact, we did have to beware of polar bears. We were not allowed more than 2 kilometers out of town without having rifle training or a rifleist with us. One of our Williams undergraduates went up the year before for a geology training summer program, and she said, yes, the first thing she had to do was take rifle training, and the second thing was training in what happens if you're dumped into the ocean and being overturned. So anyway, they really did have polar bears there, and the day before the eclipse, there was a Czech tourist who was actually attacked by a polar bear. The polar bear didn't survive, unfortunately. The tourist did, but was injured, and people wrote me from all over the world to ask what was going on, and I wrote back that we were staying close to town. We were not. He was 60 miles north of Longyearbyen. The reindeer were more docile, just by the side of the road, and it was beautifully clear. So we got to see the eclipse, the prominences. Here's the inner corona. Allison Carter from the class of '16 took these pictures, and again some ejecting of a prominence there, and then worked with a New York musician and a computer expert, Wendy Carlos, and my colleague Ron Dantowitz to put together these images. You can see streamers at all latitudes with a deficit here in this quadrant, and we're past solar maximum now, and the shape of the corona shows the phase of the solar activity cycle. And so here are the mountains, and here's the sun, and there's the shadow going across, obviously speeded up by about a factor of 10, but we actually had to go far enough out of town onto the ice so that we could see past the mountains, but not far enough that we needed polar bear protection. I'll play this one more time here. And so here's the sun, and there's the shadow coming across, and totality. Here I am out on the ice with some cameras here. And it was just a beautiful thing to do. I had only a small amount of frostbite at the end. And we got these beautiful images. Here's the diamond ring effect. Here are prominences. But the sunspot cycle continues to diminish here, and the yellow is daily images. The red and blue are averages. So you can see on many days there were no sunspots at all on the sun, and this is continuing now. And in fact, we're going further into solar minimum here. And so here is a composite image, again with an image from a spacecraft pasted on. Our alumnus Dan Seaton from about 20 years ago is running an infrared camera on a spacecraft most recently moved to Boulder, Colorado with NOAA's, National Oceanic and Atmospheric Administration, the new GOES 16 satellite. Some bright person figured out that the satellite may be a weather satellite looking down on the Earth, but the solar panels are pointing at the sun. So now they put a camera for studying the sun in the ultraviolet on, mounted adjacent to the solar panels that's just looking at the sun. And so we have this new sequence of GOES satellites that will get these observations. In Svalbard, after dawn, the temperature went all the way up to 8 degrees Fahrenheit, and then the moon began to cover the sun, and it went down and down and down, and with some delay after the actual time minimum, it went down to -7 degrees, a deficit of about 16 Fahrenheit degrees at that time. Someone we met there, C.J. McIntyre, took this iPhone movie, so it just shows that you can do very well in an eclipse with any kind of apparatus, or no apparatus at all. But she just panned around where she was observing. There were some research radio telescopes there, but you could just see the umbra, the shadow, and you can see the penumbra in the sky. So for a novice, in fact, it's probably better to take wide-angle pictures and leave the close-up pictures for the more dedicated amateur or professional astronomers. Here's Michael Zeiler's then map going further to show the total solar eclipse. The most recent total solar eclipse was March 9th last year near the equator. It went across Indonesia here, and the sky was fairly cloudy, but there were holes in the clouds, and we could see all the individual phenomena. These are with the big filters, and then these are just views of totality, prominences without any filter, March 2016. And here's, at that time, a view from the spacecraft, and it shows you how much is missing in this region that we fill in on the days of eclipses with the eclipse observations, even though you can see the outer corona here. You can see how sparse it is just at the equator in this space coronagraph. So here is another version of that movie that I saw before. I just love that movie. I'm going to play that again. So this is a real phenomenon, and we really have the shadow of the moon going across the Earth. The most recent solar eclipse was an annular eclipse, February 26th, a few months ago, that went across Patagonia, and my wife and I went down. The partial phases include a lot of Africa, the southern part of South America, into Antarctica. Here I am in this open field, beautiful blue sky all around us. The people were looking up through these filters, either in the form of goggles. I don't want to put the laser light too close to their eyes. And then sometimes just a card here, or mounting the card in a bigger protection to keep the other bright light from hitting your eyes. And you can just use these safely for all the partial phases or on any other day other than an eclipse. And here's a composite put together by Christian Lockwood, whose mother, I'm glad to say, is sitting in the third row, one of my summer students, who assembled this beautiful montage of our images in February here. And you can see the annular phase with the annulus, the ring of sunlight, is visible here. And then you can see the breaks, which are the Bailey's beads, as you see in an annular eclipse. And the filter is on through this whole part. So glad to have Christian working with me this summer on our eclipse plans, and we have him braced to put together some pictures right after the eclipse, too. So anyway, what's going to happen this year? On August 21st, there will be a total eclipse of the sun that will start in the Pacific. Partial phases will be seen even in Alaska and Hawaii, so the whole United States will be part of this eclipse. It will cross no other country. Whether that's significant or not is a political statement, not a scientific one. Partial phases will extend down to the northern part of South America. It will include all of Canada, even some of Siberia, even as part of Africa, part of Europe, for a small percentage. In the United States, we will have 2 minutes from when the eclipse enters in the middle. But there are people who say to go near the edge, because if you go near the edge, you don't get 2 minutes of totality. You might get 30 seconds of totality, but you see the Bailey's beads for longer and the diamond ring for longer as you'll be just skimming the edge of the occultation there. And then the eclipse gets a little longer, reaching a peak of 2 minutes and 40 seconds in southern Illinois and northern Kentucky, and then 2 minutes really above 2 minutes 30 seconds, maybe 2 minutes 33 seconds as it leaves the South Carolina coast. And you can see that all of the United States has a substantial partial eclipse. But when it's 70% or 60%, you might not even notice it unless you knew an eclipse was going on. You really have to have a small crescent to make the effects on the light noticeable, and then it just doesn't get dark until you're really in totality. My friend Fred Espenak, who takes excellent eclipse image, has a wonderful website at mreclipse.com, has arranged with a postal service, so they were using 2 of his images of the eclipse here, a composite image of the eclipse of the kind I've been showing you. And then if you heat it up by taking it outdoors on a hot day or putting your thumb on it, his picture of the moon shows through. And then it gets, when it cools down, the moon goes away again. So I didn't ask next door, we're next to a post office here, whether they still had any, but many post offices around. Yes, Charles, did we have? So Charles has an example here. Charles Fulco is an educator who's been devoting the last couple of years to spreading the gospel of the eclipse around schools, especially around the country, and I'm glad he could be here tonight too. So anyway, we have this nice postage stamp which certainly calls attention to this. So I rely on work from my friend Jay Anderson, a Canadian meteorologist. We are writing together the Peterson Field Guide to Weather. I've done the Peterson Field Guide to the Stars and Planets, and in updating the weather one for Houghton Mifflin Company, we wound up bringing Jay Anderson in, but he has devoted a lot of attention to getting satellite maps and doing statistics. So in August afternoons, here's the average cloudiness across the country, where 0 is dark blue, red is cloudy 100% of the time, and so this is why I've chosen to go in this area and not that area. And then I looked in this area, and I saw that there's a city of Salem, the capital of Oregon, and it turns out there's a university there, Willamette University, and they're being very cooperative. In fact, the president of Willamette University is an astronomer, and we're getting very good collaboration there, and we'll be observing from there. But most of the professionals are trying to go in this region. Jackson Hole has some possibilities there, but these are the most favorable forecasts. And there are certainly possibilities here, and for various logistic reasons, people who live close to there will choose to stay there, but that's why I chose to go here. Where the sunspot is diminishing, this is the latest compendium as of July 5th, and you see the sunspot number is about 20, which corresponds to 1 or 2 sunspots on the sun in a couple of groups, because the sunspot number actually accounts for the number of groups. Miss May Fair, is that your name? May Baum is invited me to give a webinar for McGraw-Hill Education, which is actually online. So people can still sign in and watch my lecture as recorded there, and we can, is there an obvious website, or I should link it to? I have a website at totalsolareclipse.org with all the Williams expeditions over many years, and we can add a link to that from this webinar that I gave for McGraw-Hill Education a few weeks ago. So anyway, here is the latest compendium. You see many days. The sunspot number was 0. There were no sunspots on the sun, and that's where we are now in the sunspot cycle. So in the NASA visualization from the Goddard Space Flight Center, the shadow of the moon is falling on the Earth. We're looking from the backside, the dark side of the Earth, as that shadow goes across the United States. And here is the path. You can see the partial phases, 0, 20, 40, 60, 80, 100% coverage here, going across Salem, Oregon, and a little north of Boise, Idaho, and coming across Casper, Wyoming, and Nebraska, a little south of Omaha. Part of Kansas City is in totality. Part of St. Louis is in totality. Nashville is near the edge of totality. And Charleston, South Carolina is where it exits off to the side of the totality as it ends. And then the partial phases through the rest of the continental United States. And so here's the path in detail. The professional map maker Michael Zeiler has put this together. Here's Idaho there, Wyoming. So I've learned a lot of geography, and if you bring your kids in, they can learn a lot of geography this way to study. The question is whether Iowa is in totality. You see just a clip that little bit that was similar with Montana. So some people in the solar eclipse mailing list that Charles Fulco and I are in are fighting over whether it goes through 12 states or 14 states because it clips those. So technically it goes through parts of 14 states, although there are tiny bits of 2 of those states exiting at Charleston, South Carolina. This is the weather last year. Oh no, we're going back now. This is 2011. So in 2011, you see it wasn't so great over there in the southeast. It was fine over here. 2012, it was still okay in Salem. There were some clouds coming through Idaho here. Wasn't great over here. 2013, some clouds, but still clear enough over here. Clouds in the middle of the country, not so great over here. 2014, similar over here, some possibility of seeing it, various cloudy regions. Now it was clear in South Carolina in 2014. There are people who want to go to Nebraska because there are some interstates you could ride along. And if you're on the road by yourself, you can go at 65 miles an hour. If you're on the road with 65,000 other people, it's not really clear to me how mobile people can be on eclipse day. And this time, my group is not going to be mobile. This year, I don't actually have our Oregon portion here. That was 2015, 2016. You see it was clear. All the western part of the track, and not so great here, possible in South Carolina. And then this is last year without the path actually drawn on it, but you can see it was clear across the country except here in this part of North Carolina and Tennessee and Kentucky here, but we would have done fine last year on August 11th there. But if all you want is a partial eclipse, then you don't actually have to have a totality. In 2021, there'll be an annular eclipse that comes down to Canada and Siberia, and there'll be partial phases over the whole eastern United States. Where am I today? New York City. There, you'll have a partial eclipse here. A couple of days ago, for the anniversary, we were at the National Solar Observatory in Colorado. Nick St. Fleur was there too, and there won't be a partial eclipse in 2021. But here's the path in the eastern United States in 2021. Then in 2023, there'll be an annular eclipse that crosses the United States from Oregon to Texas here. So if you're in the annular eclipse, that's fun. You saw Christian Lockwood's nice compendium there. If you're off to the side and you're getting a 90% or a 98% eclipse, doesn't matter whether the people in the center were total or annular. So 2023 is really being overlooked by a lot of people, saying when you get another chance to see that. And you see most of South America will have the annular eclipse or the partial eclipse too. And the path here will, in Los Angeles, for example, will be 78% covered as this path goes down. And in Salem, Oregon, they'll have another chance just for a partial eclipse, 93% partial eclipse at that time. And then in 2024, there's actually another total eclipse that comes across the United States with a path from Mexico and through Texas and out through Cleveland and Buffalo. Even Middlebury College in New Hampshire is in totality, goes out through Maine and out through the Canadian Maritime provinces into the Atlantic.